My guest today is Barbara Belvisi. Barbara is the founder and CEO of Interstellar Lab, a company building autonomous biospheric systems designed to grow plants in extreme environments. From controlled greenhouses on Earth to plant research modules destined for orbit and eventually the Moon and Mars. Before founding Interstellar Lab, Barbara worked in venture capital and helped build one of Europe's leading hardware investor communities, before deciding to move from financing technology to building it. Her work sits at the intersection of biology, space exploration, and climate resilience, raising difficult questions about how we preserve life on Earth while also preparing for a future beyond it. Technology moves exponentially, yet life remains fragile. As we look beyond Earth, survival becomes a matter of care, not conquest. Precision agriculture in space forces us to confront how dependent we are on invisible systems. Closed loops of food, water, and energy that quietly sustain us. And how culture, in turn, depends on the stability of this delicate machinery. In the years ahead, becoming an interplanetary species will test whether we can preserve not just life itself, but the values, responsibilities, and relationships that give it meaning. Through this conversation, we can explore whether the architecture of our current civilization is something we can carry with us, or something we risk leaving behind. I'm Kyle O'Brien, and this is State Change. Hi, Barbara. Good to see you. Thanks for joining State Change.
Thank you.
All right, I want to start with one of these big visionary questions, okay? We're going to picture it's 2050. We've already got a moon base. Maybe we've got a new base on Mars, an emerging one. But it's developed. We've got thousands of people living there. We've got a small space economy. Interstellar is, of course, a part of this on the food production and habitation side. What I'd like to know is, how exactly does food production and local cuisine look on the moon and Mars in 2050?
Well, that's a very cool picture. It's a very exciting future. I think if you think about moving the civilization from Earth to other planets, I'd love the fact that you can see us there and bringing our technology so we can grow food. How it looks like? Well, I think pretty much, in 50 years from now, especially on Mars, you'll see a lot of greenhouses, controlled environment agriculture with a lot of different species. And it's not only about the food production system, it's how we can integrate food, oxygen, capturing CO2, recycling the water, and creating this closed loop biospheric system like the one that we have on Earth. And the food will be very diverse, a lot of different crops, different species, but it will not only rely on agriculture. It will be complemented by different source of protein, probably synthetic protein. But yeah, very diverse.
Yeah, let's put it this way. So we're both citizens on the Mars base in 2050. I want to go out with friends for some drinks and a night out. It's Friday night, right? What does the cuisine look like? What are the restaurant options I have on Mars base?
Well, I think it will be combining, fruits and vegetables we'll get from plants. Probably they will have been a little bit genetically modified to survive on Mars because the conditions are different.
Yeah.
And plants will react differently because mostly gravity is different. So they will probably have different composition. I'm not saying that in 50 years from now we'll see gigantic fruit and it's going to be very different from what we have on Earth because it's going to come from Earth to Mars. So that's going to be a combination of fruit, vegetables, things we usually eat on Earth, and then more like synthetic, especially for the protein. I don't see humans bringing cows and
livestock to Mars.
No, I don't think it's gonna.
There's not going to be a supply chain of livestock.
No, it's not the most efficient in terms of like resources.
Yeah.
The use of resources, the resource that you need for livestock is like
maybe useful for terraforming with all those cow farts.
Yeah, terraforming is we need to recreate an atmosphere, so. Sure. So that will take a little bit of time, but yeah. So combination of all. And of course, we'll make wine and different type of beverages.
Okay. Now we're talking Martian wine. Okay, let's bring things back down to earth a little bit. So, Interstellar Lab, you're working on kind of precision biopods. We'll talk a little bit about the specifics here that enable you to grow unique strains of plants and botanicals here on Earth, but you have an ambition to bring this into space,
Yep.
in low Earth orbit, eventually on the Moon and Mars and beyond. I'm curious how you came to this problem, because it's an intersection of, I think, multiple different strands, or multiple different disciplines. I mean, you have to understand a little bit about AI, a little bit about agriculture, a
Yeah.
little bit about the space industry. So
Yeah.
how did you come at this problem? Why are you the right person to
To
solve
do
it?
this?
Yeah.
Well, I think so. First, it started. It's more as a yeah. It started. Go back to childhood. When I was a kid in Poland, my grandparents, they had greenhouses. I spent a lot of time in the greenhouses, reading a lot of sci-fi.
Mm.
I was a very nerdy kid, and I always dreamed of bringing life to other planet. For me, it was something that we needed as a humanity, as a civilization. We needed to work on how can we make life expand out of the earth, and this is something that I thought of in a very, very young age. Then, well, yeah, I did finance, and then I was a VC and I was investing in other companies. Then I left and I started working on what are the problems we have on Earth. And I wanted to build a product that will bring a solution to some of the problems we have on Earth. So I was really focusing on, trying to find which problem I want to bring a solution to. And the first one was fashion. I was really not interested in this one. Fashion, very polluting industry. The second most polluting industry was agriculture. And then I was like, my grandparents at farm. I always loved plants. I was collecting plants when I was a kid. I love this. This is something I'm very passionate about. And so I started working on designing a greenhouse for Earth. So to tackle some of the Earth problem that we have in space was not, at the beginning, it was not there. And then, SpaceX proved the reusability of their booster, and everybody was, looking up into the new area in the space program. And the vision that we're going to go back to the moon and we're going to become a multiplanetary species. So the childhood dream of becoming multiplanetary kicked back. And then I was like, well, there might be a way where we can do a greenhouse on Mars, spin off the technology, and have a greenhouse on Earth.
Yeah.
That's how it started.
Interesting. And what is I mean, when you're going out and raising money for this, that's a pretty big vision, right? That I think you've been able to bring it down to earth, because there's clear use cases and applications today. What was the first response from investors and whatever the broader startup community when pitching the idea of sending one of these biopods into space?
Initially, the response was a little bit harsh.
Yeah.
Especially in Europe. People are like, well, you started a VC firm, you were investing in the tech industry. Now you want to build what? Greenhouses for Mars application and then apply this technology on Earth. See, it was not very, well, I had support from fellow entrepreneur, visionary entrepreneur who started AI company, robotics company. They were supportive. They were into the same vision, that there was a very big mission that we have as a civilization to become multiplanetary, and the technology that we're developing can be a stepping stone toward that. But then I had to fly from Europe to America, and because it was really hard here to get support. And then when I arrived in the US, I got introduced to NASA and I got a lot of support. They thought that it was a crazy idea, but the business plan makes sense. Started by designing a conceptual greenhouse for Mars, which show a lot of resiliency in the system, automation, efficiency in the resources that we use, and then spin off the technology for terrestrial application. And the model of spin off has been used by NASA since the beginning. And so there was a good plan. We didn't know who were going to be our first customers on Earth, and then we figured out. But yeah, it was hard. And then along the way, proving that we can build system for NASA, that we got their approval. Then we build a system here. Then we sign contracts with customer here. Then it's get easier and easier for investors to get on board. They're like, oh, it's a crazy mission, but it's actually, one step at a time. They're delivering.
Yeah.
So that's how we're raising money. People are like, they're delivering, the vision makes sense, and there is customer attraction.
And how do you balance the kind of earthbound objectives, from your enterprise customers who are interested in a specific strain of a plant or some sort of modification or something hyper specialized, and the idea of long-term habitation, sustainability, food production in an outer space context?
Yeah, so there is a lot of back and so it's the same team, the same engineering team that is
Okay.
working on both. And usually the way it goes, we always start from space. So initially we started with a greenhouse concept. More recently, we built a food production prototype for NASA. And now very recently, we're working on a small plant growth chamber for low Earth orbit. And every time we work on these, space dedicated products, it went from concept to like a payload that we're actually flying next year. As when we do this process, there is a lot of things that we learn along the way. And I will take a few examples, but for instance, the food production system we built for NASA, it was required that we could not interact with the crew that will operate it as if they were in a space station. And there was, only very short period of time during which we can have communication. And we had very limited crew time. So we needed to really optimize the automation of the system and make it very efficient. And the requirements in terms of like how much water we were given and how much power they can give us were constrained to optimize the design. And so from this product design that we did with the space constraint and mass and resource constraint, we move ahead much faster in automation and being much smarter in how we use the resources. From that, we just reapplied those same principle into our Earth product, so which make them more efficient in the way we use resources and in automation. And it's the same thing that is happening right now with the system was designing to go in the InVast station. You start with a vision and a big concept, and then you have to reduce, cut everything to like really a super simple product.
Sure.
And basically you haven't cut enough until the product is not working anymore. And then okay, this was right. This was the right thing to do. And then we have to add what we actually cut because otherwise it's not going to work.
Right.
And so we did this process just like a few weeks ago, doing design review, and we really simplified a lot all the engineering. We diminishing the risk of failure. We're going to do the same thing and the same approach on the new Earth greenhouse that we are releasing next year. And so, but it's only because there was so much constraint on the space program that we had to make those hard decision. Then we know how to do it, and we're going to do the same on the Earth one.
Yeah.
So that's how it's space is really helping us.
Yeah. Well, the constraints help you on the engineering side to help you
Yes,
refine the
exactly.
product and get something really hyper efficient.
Yeah.
I'm curious how SpaceX and the kind of declining cost curve of launching payloads into space has impacted you guys. So presumably it makes it so it's more accessible, but also the constraints might actually be slightly loosened now because it doesn't cost as much to get, a kilo into space.
Well, the impact for us right now is more on how do we interface with the different vehicle that we are flying with. So the cost is going down, which is awesome and great. For everybody in the industry. For us is like still we have a payload that is inside another module. So we have to plug our own life support system, the life support system for the plants, which is kind of similar than the one for the human, except you want more CO2 than oxygen. Well, it's different. It's not the higher humidity, but it's the same, principle. And so we have to plug our life support system to the space station life support system. So we have to make sure our system is working with the station. So now it's really about getting into this standard of interfacing and making sure the technology we developed can be adapted to different vehicle.
Right. What did you learn in your trip to the US originally when you spent time with NASA? I don't know if you spent time with SpaceX and the team there. I assume there was a number of people you met. How did that inform your approach on developing the biopod and the strategy for Interstellar?
Well, I'm not an engineer. I'm not a scientist. My study were finance and business, and I was an investor. I'm very passionate, and I learn things. So when I arrived, I think first it was the interest I was gaining from people. So I can see that when I was speaking about this crazy vision, there was an exchange. I was like, okay, I'm not like this. In Europe, I was this crazy person. And in the US, I was more with my family of like-minded people. Then more specifically, NASA was very pragmatic. It's a small team space portal at NASA Ames. They give me a desk, a huge book, 300, 400 pages about the space station
Yeah.
and how the life support system work there, what's not working, what needs to be changed. And I was meeting engineers and astronauts and people just like giving me information. So most of the time at the beginning when I was in the US, I was acquiring information so I can refine the plan.
Right.
And in America, people are very willing to see you succeed. So they give you a lot of information and they feed you because they want you to succeed if they like your mission.
Yeah.
So that's what happened there.
Yeah. So what I find interesting about the kind of current space age is that it's primarily driven by the private sector.
Yeah.
If you think back to the Apollo missions, this was more of a geopolitical space race, and I suppose some of those dynamics exist today. You spent time with NASA, you spent time with SpaceX, you spent time with Vast and other space industry companies. What is your point of view on kind of developing policy and like top level decision making around the strategy for becoming an interplanetary species? Is this going to be primarily decided by private institutions or public institutions? And what do public institutions need to do in order to adapt if they're falling behind?
So currently, private companies took over. It's done. They took over the engineering, the development of the technology that is required to become multiplanetary. SpaceX just show the way to become independent from government money. So there is very few revenue actually SpaceX is making with the government money. It's mostly through commercial application. And so that showed a way to many other companies on how private companies shall not depend only on governmental funding to develop the technology. So the technology development is on the private company side. Currently, many private companies still depend too much on government funding. So but it's still, it's still, to be honest, it's still a geopolitical war that is happening right now. And the truth is the space race is, America versus China. And it used to be America versus Russia, and now it's China. And it's a real race. Like this is when I'm in the US and with all the people I work with, this is what we talk about: is how are we going to beat China on the race to the moon and the race to Mars. So it's still very geopolitical. It's very driven by the willingness of the government to support in the financial way, but also in a more in a vision way. So it's like getting an entire country mobilized around this idea of becoming the leader, to be back on the moon and to be the first one to, so it's still there. It's different because now it's really, the engineering is really developed by private companies. How it's going to unfold when it comes to, how do we build new civilization on the moon and Mars? For me, I will consider the moon to be very state-driven because it's super close to the Earth. You actually don't need a greenhouse on the moon. You can just get resupply from the Earth. It's going to be like 2 days flying food. Pretty much, if you don't eat for 2 days, you'll be fine.
It's like a slow Amazon order.
Well, the problem is going to be oxygen and water is hard. But but it's not like if you don't have moon is not, because of where it's located, it's going to be hard for the moon to be independent. And it's really, I see more the moon really as a stepping stone towards, getting to Mars, which is like, this is the real deal. This is the only planet where we can go in our solar system, so we can become multiplanetary, at least for now. And so I think on the moon it's going to be still very stage driven. On Mars, I don't know. It's far. So, I don't know. The first people who will get there, will it make sense to be, representing a nation and a country? And especially when consciously, our mind might shift as well, because life is not going to be only on the Earth, but it's going to move to Mars.
Right.
And so does a nation make any sense anymore? Like, aren't we Earthling on Earth and then on Mars? And so I think it's really hard to predict. On the moon, governments and the way our world is currently designed, it's very close. So I see it's pretty much going to be very similar. On Mars, I think it's going to be hard for governments to control. how it's going to spread.
Mm.
You know,
Why do you think it's important to become an interplanetary species?
I think it's not only about humans. The reason why we do interstellar is not for human to become interplanetary species. It's for life to expand.
Mm.
So if you put in in the big scheme of things, Earth is like 4 billion years, and it's at the mid age. It's like at its 40s, so
Yeah.
it's having a existential crisis right now. And currently, the only place that we know that has been able to create not only life but consciousness is Earth. And at a certain point, if you put in the perspective of very large scale, the sun's gonna blow and life on Earth is gonna disappear. And I think becoming multiplanetary is about just making life expand, because we want consciousness and life to expand. So it's it's a first step towards something that is much bigger, but we need to make those first steps. If we don't do it anytime, consciousness might never spread around the universe. And you can see, well, it's very self-driven to think that consciousness is only on Earth. Well, we don't have any proof now,
Right.
otherwise. So it's
Well, I mean, to me, that sounds like a very virtuous objective. I think from a personal standpoint, from a personal philosophy, it totally makes sense, even at a humanity scale. The challenge is that there's also commercial interests and government interests. And so what you alluded to before is the moon maybe becomes some sort of geopolitical proxy or some sort of, I don't know, defense strategy. Mars, it's unclear how the territory is going to be staked out and how we're going to govern it. What do you view all of these kind of competing forces as something that's going to end up being extremely problematic, or is there a way to kind of unify humanity in a single kind of direction?
um, humans, we evolved by developing culture and society. And so the way we developed around the Earth is family, village, you create a culture, and then it spread. And then there's another idea and another form of culture. And it keeps going like this. And it spread like this. And you have a lot of diversity. And so I think, I hope that when we go to Mars, the same thing will happen. Like, people will be different because they're not on Earth. So it's like we have no idea how humans are going to react to be separated from their home planet. And I hope they'll react well. And my favorite book is the Martian Chronicles from Ray Bradbury, and I find it very funny because they are very short stories, and each story is about a new rocket. They look like a new starship arriving on Mars, and just there is a whole new story of how people are reacting and creating different things. But I think, again, if you look at how everything's evolved on Earth already in terms of the society on Earth, it's spread, it's very diverse, and I think pretty much the same thing is going to happen on Mars. And I hope it creates a shift in our consciousness. Like, we realize that it's there is no point of, like, we're on a rock that is moving around a ball of fire. And we take the metro every day and we ask ourselves silly question. I think everybody should be thinking about the universe, what we do, our place there. And so I hope it helps that people getting more interest into this, and taking a different perspective, and sometimes looking at the problems, be like, oh, we shall not have this problem. There is much interesting things to work on, like, how is this plant going to grow on Mars?
Well, I think you bring up an excellent point, which is storytelling is really important for this industry. It was important back in the Apollo era. It was, this is something that people can rally around if you position it correctly. If it's not positioned correctly, I would imagine there's a lot of criticism of the space industry. I mean, you see it in the media all the time. Why are we allocating so many resources towards building, a billionaire's, encampment on Mars or on the moon, when we could be allocating those resources towards whatever, feeding the bottom part of the population in the on Earth. I think there's obviously a balance there. I think it's important to illustrate what we can achieve as a species, as a uniform kind of group population. But it's also important to balance that with like the realities on the ground, right? So what kind of stories do we need to tell to get people excited about this? If it's not going to be a national identity story, the US is beating Russia, or the US is beating China. It's more private sector companies are, advancing science, and there's an idealism to it, but it's not the same as a national identity. So what is the story we have to tell? I think you Interstellar, you guys put together a lot of interesting stories.
We try.
Tell me about like how you think about that. How do you get people excited about this?
Well, it's a very good point. We still get the criticism about, why do we want to bring a greenhouse on Mars? And when very pragmatically at Interstellar, we have spin-off application and we have customer on Earth, and we use the technology we developed for space to, use less water, recycle the system, have non-polluting plant growth chamber, reducing the supply chain, the CO2 impact and everything. So we have in our company, and it's in our DNA, we have this very obvious that it's actually useful on the Earth. Then on the more general side, the first thing is the vision of becoming multiplanetary. There is a misconception that multiplanetary is about leaving the Earth. And it's like, let's go to Mars because we don't believe the Earth's going to make it. No, because in the multiplanetary, there is multi, which apply too. So the plan is not working if the Earth is not okay. So people who are working towards the multiplanetary plan are not thinking we should escape the Earth.
Right.
They're thinking the Earth is so beautiful and so amazing that we should try to bring a little bit of this life to other places that are dead rocks now. I mean, there is some life on Mars, but...
But you could imagine a counterfactual where 200 years from now, perhaps Mars selected for our most ambitious, most creative, most interesting, most driven people, right? And they build a colony and they build a culture. And over the course of a couple hundred years, it far surpasses the kind of innovation that's taking place on Earth. I mean, this is a hypothetical. And slowly but surely, kind of Earth starts to deteriorate a little bit. Perhaps we don't have enough resources here. People start to flee. Is that a scenario you envision? Or do you really think that it's possible to kind of balance the two and maintain cultures in on Earth, on Mars, on the moon?
It's a good question. I was telling you about this back and forth that we do at Interstellar between Earth and space. I will really, in this scenario, I will really encourage to have company that do both. Because then they can leverage, of course, the technology that will be developed on Mars and for Mars is going to be, more optimized in terms of use of resources, use of power, recycling the different systems. So much more designed for sustainable living that we did on Earth, because on Earth we didn't have those constraints at the beginning. So there is a lot that we will be able to learn from Mars, but to pass on this knowledge and this technological innovation, well, it works if it's driven by a company that has the ambition to do both.
Sure.
And that will, then it's but I think we can pass on. And as soon as we pass on and we keep on doing it, I don't see the separation.
Okay, I want to talk pragmatically about the upcoming missions that you have. So we've talked about the ideal 50, 100 years from now, but there's a number of milestones, stepping stones in order to get there. Part of that is launching into low Earth orbit. Part of that is launching to the moon. Then it's to Mars. Then it's beyond. But walk me through how you're thinking about those steps.
Well, currently, very pragmatically, we're flying next year. We designed a small plant growth chamber that's going to be integrated into vast space station, vast a private American company building the first commercial space station, and as part of one of the players that are existing to replace the International Space Station that's going to be decommissioned. And so we're currently just, going through all the design review, the certification and testing, so we can make sure the plant growth chamber is going to be functioning in this first module. And then the second step, and that we go next year. So now we're validating all the choices that we made, technological choices, all the constraints as well that we have, because there are a lot of constraints because it's a new module. It's not like the ISS that has live support 24 hours, 7 days a week. It's not days and week up there.
So it won't be a manned mission. It's going to be completely
so
remote.
The station's gonna be it's gonna be put in orbit with space. So SpaceX Dragon put the station in orbit. It's gonna be unmanned. And then 45 days after it's orbiting the Earth, then Dragon's gonna bring 4 astronauts. They're gonna spend 2 weeks inside Haven 1. Our system will be attached, integrated in the space station, and then with the astronauts will carry bags, and in the bags they will have a small system that will just plugged in into the space station for 2 weeks. It's going to be operating, so it means you have a live support system that can support humans. So you have the atmosphere and everything. Then when the astronaut goes down with a Dragon capsule, then you don't have life support. So it's actually a tough one to manage in terms of how we integrate our system. And then after Haven 1, there is Haven 2. And Haven 2 is a permanent space station. And then the next step for us will be to integrate our system within their space station to conduct plant research and food production and to see how plants react, because plants react differently when you have no gravity.
Sure.
So they develop differently, and we need more data. We need to study how they flower, because before the fruit, there is the flower. So you really need to understand how to trigger the flowering of a plant in a microgravity environment. So that's what we will do. And then we have a plan for 27 to have a small payload, small plant growth chamber, integrated inside Astrolab rover. So the rover is gonna go. So they have different missions. One mission is with SpaceX. The other one is with Blue Origin. The Blue Origin lander will carry the rover. Starship will carry the rover. Inside the rover, there are gonna be different payloads. Small boxes. One of this box gonna be a plant growth chamber. So an iteration from the one we did for the space station, but a bit different because we need our own power. Temperature is going to be tricky. It's very cold on the moon and we have only 10 days of light. And so it means the experiment will not be able to last longer than 10 days.
Right.
That's planned for 27. And then we will rely on the, SpaceX program and NASA program to go to Mars, because we don't build rockets. We just build the plant growth chamber. And it's tricky. It's a long trip. If you send seeds, they're gonna, grow during the trip, 6-7 months. What we're focusing on is how we can, and this is what we are doing now, is how we put plants asleep and then we wake them up when we need them to wake up.
Yeah. And what is the significance of the payload? So you're sending a flower into space.
Yeah.
Tell me more about why that was the first choice. I mean, you could have chosen any plant. You chose a rose.
Yes.
What's the backstory there?
So the backstory is the Little Prince. So I mentioned at the beginning, my grandparents were farmers in Poland, but we're 3 sisters, and our parents, they loved the Little Prince from Saint-Exupéry. So it was all around the house where we were kids, and we had so many foxes and a small statue of the Little Prince, and it's a very profound story. It's more of an adult book than one for kids, but we loved it. And so as soon as I started working and doing Interstellar, then one day we were thinking of the putting the greenhouse in the moon, and I know we were discussing at the office, and then the idea of the Little Prince just came, and we're like, let's send the rose, because the rose is the symbol of love. And it's a hard species to grow. If you know how to grow roses and to flower roses, you can do tomatoes.
Okay.
So it's a hard one, and also it's about the cause and and what it means. The Little Prince is the most read book on the planet after the Bible, and the religious book. It's been translated in like so many languages. I had no idea there was that many languages, to be honest. And so we have this mission of bringing the rose to low Earth orbit. Then we're going to bring the rose to the moon, and then we'll bring the rose to Mars. We will learn a lot about the flowering, the fruiting, how the plants develop. There's a lot of research that we're working on, and that will help towards building the food production system.
Right.
But most importantly, we want to create a mission that can, resonate to as many people as possible on Earth, and create an emotional link with space exploration. And, as soon as you know that there is a rose growing on the moon, I can assure you that when you go to, to buy a flower for your boyfriend, girlfriend, mother, father, you will look at the rose differently, because you will remember that there is a rose growing on the moon, and that soon this rose is going to go to Mars. And we hope it's going to create something,
It's almost the opposite effect of the what was it, the moonrise picture, the little blue
overview
marble,
effect.
the overview effect, that all of a sudden people started to see Earth from the moon's vantage point, and it had like this cultural shift around what it meant to be an Earthling.
Yeah.
The same kind of thing is now we're projecting ourselves out into the stars with something that is relatable for every individual. I mean,
Yes.
rose means something to virtually everyone on the planet.
Exactly.
Right.
Yes. And
Yeah, it's,
and there are very beautiful sentences in the book The Little Prince, where I don't remember the exact words in English, because I know it in French, but it's enough for one person to know that there is a rose growing on one star to make all the stars look beautiful. And this is what we want to create, is this, be like, wow, there is life outside the Earth. And it's beautiful life, and it's a fragile life. Also, the flower embodies something that is very fragile, very ephemeral. Doesn't last long. It's hard to get, but it's beauty. It smells well, and eventually it gets you a fruit, and it can feed you.
No, I think it has a nice kind of symbolic aspect to it, but there's also something very concrete and scientific, right? These are milestones. This is like the test mission for doing bigger and bigger missions, or more and more complex missions with a variety of, or a varietal plant species. That's interesting. I want to talk a little bit about how this is kind of a modular approach. So you're starting with these kind of cubes, right? It's effectively a cube that's going to slot into the commercial space station with VAST. Eventually you could aggregate 50 of these cubes, right? To build a larger system.
Yes.
And they could all interconnect.
Yes.
And then eventually you could probably send the materials to build something from scratch on a base on the moon or Mars. But this first step of integrating it into like a commercial space station like VAST, I think is really critical, because first you have to design it with the VAST system in mind. So there are design implications as a result of partnering with someone specific, and that will have a downstream effect on like essentially all of the future engineering that you guys end up doing to one degree or another. How important is it to, I guess, align super closely with a particular partner? I mean, you got to choose someone that you can trust and that you think is going to have kind of longevity in the space game, so to speak.
Yeah. So what's happening is actually we all go back to all the NASA specifications.
Okay.
So
that's the blueprint.
That's the blueprint, and also we're flying with SpaceX and Dragon, and so VAST life support system is attached to Dragon life support system. So it has to be be certified based on what SpaceX wants. And then as a blueprint, we have the NASA requirements, and then we have the VAST requirements that are very aligned to the SpaceX requirements. Right. But they're trying to standardize everything. So, how you plug in your system is you have different ways of plugging your system. We're trying to make it super standard. So when you move to another provider, you're not going to have to rechange everything.
It's pretty amazing how standards work. Like the person who defines like the first approach, I mean, the lock-in is pretty strong. Pretty strong. Okay, so how do you think about you're working with these partners that are building low Earth orbit space stations? It's been a kind of a bit of buzz recently in the tech community around building data centers in space. This is the hot new topic. Bezos is talking about it. Musk is talking about it. There's a number of companies. I think one of them is called StarCloud that's been on the timeline recently. what are the implications of having effectively floating data centers on interstellar biopods? I mean, is this something that where you could kind of offload some of the compute there and
Yeah.
perhaps redesign the the biopod itself?
So first thing, I'm a big supporter of data center in space for a long time. But the business model makes sense if you can control the entire chain.
Yeah.
So if you can control the cost of bringing everything up there. So that's going to be big companies game. And some startups can add something to it, and can develop um, other solution, but it's a big one and it's going to happen and it makes total sense.
Yeah.
And that's for sure, and especially with the development of AI, I think we needed to reach a certain point with AI for the business case to make sense
Yeah.
in space. But it's the idea's been around for a very long time actually. Then when it comes to us, well, we do. So the biopod are intelligent system. So they're equipped with different sensors, cameras. We have microcontrollers that control all the machinery. There is intelligence at the biopod level, and then there is intelligence in what we call the mission control. So this is where we aggregate all the data about all the plants, all the information, all the biological information that we have, and then we add all the climatic condition and everything. And then on that we train the algorithm, and for that we use. We have servers where we store the data. There's not that much data that we need for us to operate. So in terms of, in the future, maybe we can rely on a data center on Mars and just have our algorithm just be running directly there,
Yeah.
without needing to run through, with the Earth. That actually makes sense. Yeah.
Okay. I think on the topic of commercial companies, startups, kind of being the dominant force in the space sector now, I'm curious where you draw the line between what startups are going to be really good at and where government should step in. Inevitably, there are going to be things that we need government for. I'm
Yeah.
curious where they're best suited to kind of support in the current space age.
I think government or space agencies, they're there to facilitate the development of space technology, and so by defining a roadmap with objectives, deadline, unlocking financing, so we can do more scientific experiments, more research. But the research, the technology, all the engineering has to be done by startups.
Mm.
It cannot be done by, and I don't think we ever going to go back to that. So that will be where startups and companies are playing, is really in developing the technology and the engineering. Then we need a lot of, we need a lot of financing when it comes to science. So it's Dyson Freeman and also Tchaikovsky. There were Tchaikovsky before Dyson Freeman, but they mentioned there are like two big problems with space exploration. The first one is the engineering problem. We need to design the rockets, the vehicle, all the system, so we can bring life to another planet. But that's a solvable problem. It's engineering. So you require talents, investment, and we understand how a machine works and how we can improve and how we can make it work. So that's a solvable problem. The second problem that is much harder to solve is the biological one, because we have no idea how biology is going to react and develop outside the Earth. And so I think this is where the support of the government is needed, is of course to facilitate the engineering part, but I think it's pretty much very well established now, the companies that are building and the technology development. The second part, the biology, how humans are going to react, how life is going to react, how microbes are going to react, it's still blurry.
Yeah.
And we need much more financing. And, there are a company like us where we try to find a business model on Earth so we can finance the space research and the space development. But that's hard to do. And this is an area where we need the government to step in and I think give more money for research and science.
It certainly feels like a critical inflection point for the space industry. There's kind of a space renaissance, right? We had the
Yeah.
Apollo missions, we had the space shuttle, and things died down for a while. I think NASA kind of fell out of the public imagination, and now there's this reboot. It's SpaceX. It's these new companies building orbital data centers. It's these companies building commercial space stations. It's the Interstellars of the world. I'm curious if we project ourselves 100 years into the future, if you were looking back on the history of this moment, what do you think is the biggest pitfall that we should avoid? What is the biggest, how would you prescribe to today's leaders in the space sector what plan to take?
I think we should go full on Mars. And the moon is important, but Mars is how we really change this is how we make life multiplanetary. That's a huge shift. Like Earth life is not multiplanetary now and has not been for 4 billion years. And it's a huge inflection point to make life from Earth go to another planet. And so I think it will be very sad if we miss this train, if we're too, if we don't push towards the Mars program. And it's repeated. I mean, it happened before, like, in the 60s, we're like, let's go to the moon. And there was like so many Mars plans. There were like tons of plans to go to Mars. And then it faded out. And I think it's important we don't miss this train right now.
Why do you think that was?
Why it stopped?
Why did it fade out?
Well, because I think it was at the time, there was one project which was actually Project Orion that I discovered recently. I had no idea that was the name, but they had a whole plan to bring humans to Mars, and then the financing, the political, it was not strategic for politics to finance. They had other stuff to finance, and the public opinion was interested in different things. And then when the space shuttle program was shut down, it was hard to get, everybody back into supporting space exploration. And so that's why when private companies took over, it was good. And so now it's okay because it's private companies, and those private companies have a pretty solid ground and basement, so they're not about to disappear. They're consolidating, I will say. It's big companies is leveraging on the other, sister company, whatever they're doing. You know what I'm talking about. Yeah. So it's important we don't miss it now, but I think we're not going to miss it. I don't know. I feel it. I feel we're going.
So if you were coming back from the future, you're a time traveler. 100 years from now, you come back to today, and you were to talk to the leaders of the space industry and government sector that are working on these problems, you would say, get to Mars. Don't miss the opportunity.
Do the moon, get to Mars. Yeah.
Okay. So you mentioned when humanity expands onto the moon, onto Mars, we're going to develop unique cultures. We're going to develop our own customs. Some people will react positively, some poorly. I think all of this will be an interesting experiment for those first manned missions. What is your point of view on how this will develop? Do you think that most people will be able to adjust, or it's going to be much more challenging than we anticipate?
So I think we'll miss the Earth at the beginning. So that's why it's very important to bring a little bit of the Earth with us. The smell, the colors, the plants. So I'm preaching from.
You have a slight bias, but
exactly. But so we'll miss the Earth. So it's part of humans have never been detached from their planet. So if you think about just during the pandemic, when we're isolated at home, many of us turn into gardeners, and so we needed a connection with something. So we'll miss the Earth, but then when it comes to society development, I think it's very important who we send. You need optimistic people. You need people that are happy. And that are very joyful in building different things, and that can change the whole dynamic of a group. You want social people that can communicate. So it's I think it's going to be much more based on, of course, the skills, but it's like the personality traits, their resiliency, and be a happy person. Sounds kind of like silly criteria, but I think it's very important.
No, I think the selection criteria is pretty important, especially if you're going to be living in a small pod with 6 people,
exactly.
millions of miles away from home.
Yeah, you have to be adaptable, and I think being happy and
yeah,
it's going to be one of those things. If we only send sad people that are too serious and too introvert, I'm an introvert, but you need a combination of different personalities. But it's I think the criteria are going to be much more psychological actually than engineering
Sure.
base. You need a mechanics. You don't need a mechanical engineer over there.
Right. Right. Okay, so you're spending a lot of time with your early customers here, building new custom strains of plants that are useful for cosmetics or perfume or whatever the industry might be.
Ingredients. Yeah.
As you move into an interplanetary context or a spatial context, you're selecting for traits that are adaptable for a microgravity environment, for
Yeah.
example. But in the long term, you can imagine you're going to design for all different types of factors that perhaps we hadn't considered before we landed and built a colony on Mars. So, do you see yourself as like it's more than just kind of genetic engineering and manipulation, but really like designing new crops and new plants and new life systems? Is that how you think about the work that you're doing?
I think nature and biology adapt very quickly and has been trained on Earth to adapt quickly and show a lot of resiliency. I mean, adapt quickly, also disappear and have to restart again.
Yeah.
And we had a lot of like extinction phases. So nature had to find a way, and it developed this ability to react fast to its environment and then try different things to figure out what's the best solution to adapt to the environmental condition. So I think biology will adapt much faster than humans will actually do in trying to bioengineer the plants. We might do some engineering, to strengthen some genes and, for the plant to be more resilient when we bring them to space and to Mars. But I think what I'm curious about is how it will react by itself and how it will adapt. There are a lot of unknowns. The nitrogen fixation is a big problem because of a low gravity on Mars. It's, it's a third of the one of the Earth. And but I think nature will find a way. And so, I don't want to sound like Jurassic Park,
Sure.
but nature is always find a way. But this is what I believe, and then we'll see where it goes. But and maybe humans will engineer, but I think nature will be faster.
Well, that makes me think, if you bring a rose to the moon or a rose to Mars, it was a rose. It started as a rose on Earth, and it was a rose when you got there. Then you can genetically modify a rose, and it's like some slightly different strain of a rose. But if you grow a rose on Mars, is it still a rose?
It's not an Earth rose. So what happened, and it happened in microgravity when you bring a plant to low Earth orbit. This is why when I was saying that biology and adapt quickly, plants, when you bring them in low Earth orbit, they change their metabolic composition. They change kind of their DNA almost. They like really adapt. It's like humans, we don't store calcium anymore because we don't need to fight against gravity because there is no gravity. So we lose muscle and strength in our bones because it's not required for our body. So we adapt quickly, and plants is the same. So technically, even the rose that we're going to send to the space station next year and that we're going to bring back to Earth is not going to be the same one that we sent, because it will have changed its genetic expression.
Well, that same thing applies for humans too.
Yes, it does.
If you go out to Mars and you come back,
you're different.
The fundamental structure of your being is different. And then one step further, if you're born there, then we end up having people. You age faster, but also, I mean, you're a Martian. You're not an Earthling, right? Or you're I don't know what you call a moon citizen, but there's an interesting.
I agree.
I don't know if that's a speciation shift, or if it's more of a philosophical delineation, or if it's.
I think it's going to be a species, after
like a branching of the.
After several generations, probably the newborns will be different than the parents, and they will have some gene expression because of the difference in gravity, the difference of the environment. It's like if you look at the evolution life on Earth, and if you look at the evolution of humans as well, like we've been through different forms, and and there are a lot of reasons why based on the environment, what we were eating, and I think pretty much the same thing is going to appear on Mars. And then the question is going to be like, when do we define that you're not an Earthling but a Marthling? That's going to be I don't know if we're going to experience that in our lifetime. Maybe.
We'll need some sort of committee or governing body to make that distinction.
50% gene that changed. You're from Mars.
Exactly. Cool. So we spoke briefly about how governments may or may not get involved in the 21st century space race. I think as individuals, we tend to tie our identity quite strongly to the kind of the nation we're, grew up in or that we were born into, the accident of birth. You're French, I'm American. We have some sort of identity rooted in that. I think it becomes a little bit trickier when you go to the moon or to Mars, even if you have the American flag or the Chinese flag planted in there. I don't think it'll really feel American or Chinese. And like we said, you're going to build your own customs, build your own cultures. Um, I'm curious, like how we'll start to think about our kind of national identity or moon or Mars identity. Is this do you view this similar to the way that like kind of early colonization looked like on Earth? I mean, are we going to have strands of people coming from various cultures and fusing into a new one and settling these territories, and as a result they'll feel kind of unified themselves, or is it going to be a different approach here?
And I don't know if let's so I'm born in France. My mom is Polish. My father is Italian, born in Tunisia, and I spend half of my time in the US.
Yeah.
And half of it here. I remember when I was a teenager, I was telling people, because I haven't been to I didn't went to the US then, but I was like, I feel very European. I don't understand the French thing. I'm not that French. I have no French blood, but I love France, but I'm Polish and Italian much more than French. So I don't know. I was like already out of the nation thing. Then when I went to the US, then I was like, oh, okay, no, I'm a citizen of the earth.
Yeah.
So, but it's true that you have some attachment, cultural attachment, and culture is good, and
But I think that's actually an important point. I know a lot. I'm an expat. I know a lot of people that expats and otherwise, kids that grew up moving around and growing up in different cultures, speaking different languages, or parents from multilingual, multicultural backgrounds. Perhaps there's something to it. Like these kind of like third culture kids are the type of people that we should select for
to go to space.
Actually to go to space, because they're adaptable, they're multicultural. I mean, maybe there's something to that.
I agree with you.
Yeah.
I agree with you. Is that so? And I mean, I think it's we did it with migration.
Yeah.
And so I'm pretty confident when humans gonna go to space and settle in space. I don't think it will be important to keep the souvenir, the memory. Because there is something very reassuring.
Yeah.
There is something that has come usually from the childhood, and it's of
comforting,
like, and it's good, and it's Christmas season, and it feels good for people to just spend time with their family and to be in their culture. So we want that. We want to preserve that, but I think we will be able to adapt, and it will not. For me, it will not make sense to.
Yeah.
I will consider myself Earthling on Mars, and then a Marsling.
Eventually a Martian. Yeah. Well, presumably you'll start, some sort of like a Martian Bill of Rights, and people will build systems of law, and people will build businesses. This is kind of the natural progression of
and then you ask yourself questions again, and then maybe we can also challenge the model that we have on Earth. If there is a new model on Mars a new form of society that we're starting building, then it gives a feedback to what's happening on Earth, and maybe we can also question the current existing model that is showing right now that it's reaching a certain limits.
Yeah, no,
and we
I
have
think
to
that's
question
fair.
ourselves, but space can really help us just by doing this exercise of visualizing what will be a new civilization on Mars.
Yeah.
We can actually get probably good ideas on how we can change the system that we have currently on Earth.
I think on a smaller scale, people are running experiments like that on Earth. You think about kind of the network state concept, people doing seasetting, building these pop-up cities that are ephemeral, but it's like a mini village with a diverse set of people with its own set of governance and identity and cultural norms.
Like Burning Man, even just
Burning Man is a great example of that. It's a festival. Yeah.
Well, it's changed over the years.
Sure.
But the initial concept of how do you live as a community, and you build things and you provide to the community, and it's different, very different to the existing world that we're living in.
Yeah. So, yeah, perhaps we just build a network state on the moon.
On the moon.
And run a quick experiment and
see how it goes.
Yeah. Okay, I want to end on I guess it's kind of a personal question. All this is personal because this is your life. But if someone were to come to you tomorrow, whether it be a space agency, whether it be Elon Musk, and says, look, we can get you to Mars, okay?
Yeah.
We want you to be a part of the first mission. You have to leave tomorrow. Interstellar is going to be involved. We're going to get you, you guys are going to be the life support, the kind of the food supply system for Mars. You have to commit to 4 years. You leave Earth tomorrow, 4 years. Small mission, high risk. Would you take it?
Yeah.
You would, without hesitation.
Yeah.
You would get on the starship.
Yeah.
Yeah.
Well, it's not tomorrow. Like it can be 28, but I don't think it's going to be manned mission. So my guess is more like 32, probably 36. So by this time, kids will be a little bit older.
They'll be able to understand.
Yeah, and I'll be like, Mom's going. I'll be back. I promise.
Yeah.
No.
But you've made that decision. There was no hesitation there.
I want to go.
You want to go.
It's amazing. It's
historic.
Yeah.
Yeah. Okay. Well, I hope to see you on the
Mars?
moon and Mars, 2028, 2036. We'll see. We'll figure out the dates.
2032.
Okay. I won't run the math and figure out how old we are then. But
Young.
yeah, still young. Still young in relative terms.
Super young.
Right? Yeah. Well, amazing. Thank you so much for joining State Change. It was a pleasure to talk to you.
Thank you, guys.